Chapter 6.3, we're looking at logarithms and logarithmic functions. So definition of a logarithm with base b. Let b and y be positive real numbers with b not equal to 1. So b cannot equal 1. The logarithm of y with base b is denoted by log base b of y and is defined as log base b of y equals x if and only if b to the x equals y. So just as a reminder, the expression log base b of y is read as I'm saying it. So log and then the base b of y. Okay, so that's how you would say it. Log base b of y equals x and b to the x equals y are equivalent. So sorry, there's no space there. So the logarithmic form is log base b of y equals x. Then the exponential form is b to the x equals y. Now I want you to notice where things are located in each of the forms. So the base b, so let's just look at the exponential form, that's what we started with before. So notice the base is b, so notice for our log, the base is now here at b, so log base b. So they're the same. Then x is our exponent, so in logarithmic form, we notice the x is here. So one big thing that I want you to notice is that logarithms equal the exponent. Okay, so it's going to be very handy when we're rewriting things, so you know it'll help you with where do you put things. Okay, so the base b goes here, and then it equals the exponent. Okay, so notice the exponent here. Then y just goes in this position here, so that's the last piece. So let's practice this. We're going to rewrite logarithmic equations in exponential form. So if we're given log, then we're going to write it in exponential form. And so we're going to take a look at all the pieces. So notice that the base b, right, is down here. And then it equals the exponent. Okay, and then we have our y as well. So when we write this, just think about the base is 2. So log, when you're reading this, log base 2 of 16 equals 4. So first thing we're going to write is the base of 2. And remember, the logs equal the exponent. So the exponent is 4. Logs equal the exponent. And then the y goes at the end, which is 16. Now you can check to see if you're right, because this should make sense. 2 to the 4th power equals 16. So remember, that's 2 times 2 times 2 times 2, and that is 16. So after you write it, you can always check to see if it is correct. So I'll try one more. So log base 4, and then it equals the exponent, right? So the exponent's here. So when we write it, the base is 4 to the 0, and then it equals the y, which is 1. So go ahead and practice with the rest. So 2 through 8, pause the video and try these out. Okay, if you tried it out, here are the answers. So notice you have 4 to the 0 equals 1, and again, that's true. 12 to the 1st power equals 12. 1/4 to the negative 1 equals 4. 2 to the 5th power equals 32. 6 to the 3rd equals 216. 7 to the 0 equals 1. 21 to the 1st power is 21, and 1/5 to the negative 1 equals 5. So now let's rewrite it in the other direction. Let's rewrite exponential equations into logarithmic form. So we need to write log. So let's do that first. So we're writing log. So log, and the base is the number with the exponent. So these are our bases, for example. So log, and the base is 5. And then remember that the logs equal the exponent. So I'm just going to equal the exponent right now, just to kind of help me out. And so the exponent is 2. So it equals 2. And then 25 is just that last piece that goes in here. Okay, so if you know the base and you know what it equals, then that last piece just goes right by log base 5 of 25 equals 2. So let's try one more. So again, so if I don't see log, then I need to write log. Log, the base is 10. And remember that logs equal the exponent, and the exponent is negative 1, so it equals negative 1. Then I know that last piece, the 1/10, goes here. Okay, so try out number 10 through 16. Pause the video and try these out. So if you tried this out, you would have log base 8 of 4 equals 2/3. So again, remember it equals the exponent. So log base 6 of 1 over 216 equals -3. Log base 32 of 4 equals 2 over 5. Log base 9 of 81 equals 2. Log base 20 of 1 over 20 equals -1. Log base 16 of 8 equals 3/4. Then log base 15 of 1 over 225 equals -2. So notice this two special logarithm values. Log base 7 of 1 equals 0, right? Log base 7 of 1 equals 0. Now that's true because if we write it in exponential form, notice b to the 0 equals 1. Anything to the 0 power is always 1. And then logarithms, if you have a log base b of b, that equals 1. Because if we rewrite it as an exponential, notice it would be b to the 1 equals b. So anything to the first power is itself. So let's go one step further and let us evaluate logarithmic expressions. So now we want to find out what the answer is. Now what we're going to do is we're going to go ahead and rewrite these as exponentials. Okay, so rewrite as exponentials first in order to help us. So remember the base is 4 here. So 4, we don't know what the exponent is, so that's what we want to try to figure out. 4 to what power equals 64. So what we're trying to find out is that x value. What is x? So 4 to the third power is 64, right? 4 to the third power equals 64. So the answer is 3. 4 times 4 times 4 is 64. Now, one other little hint that I'm going to help you with is that if you have fractions, then you'll have negative for your answers. So for example, I'm going to come back over here. So if you have 1/5 to the -1, so notice that we have a negative, we have a fraction, and it's not a fraction anymore, then we usually have a negative exponent, right? Negative exponent means it flips. And so same thing here, we have 1/4 and then the 4, so it's a -1. Okay, so notice that. And then when the answer gets smaller, we're going to notice like here, 8 to the 2/3 equals 4. So if you have a number here, the base, and then the resulting answer is smaller, we have a fraction as our exponent, or in the case of our logs, our answers. So if you have like a fraction and then you don't have a fraction, then that means a negative exponent is involved. So I'm going to write it. So fractions and then no fractions, or vice versa. No fractions. The answer usually has a negative. Usually has a negative. Okay. Then if you have a smaller value from the right to the left, so smaller value, so on the right means you have a fraction answer. Okay, I want you to think about nth roots. Okay, nth roots. Okay, the exponents are fraction answers. It's a way to make it smaller. So for example, number 17, so I'm going to rewrite it in exponential form. So again, the base is 5. I want to figure out what the answer is. What is x? And that equals 1/5. So I know that I have a whole number going to a fraction. So in order for that to happen, it's going to be a negative exponent. Now, in order for it to flip, then that's just going to be 5 to the -1. And then that does equal 1/5. So the answer here is -1. So again, it's really helpful if you rewrite it in exponential form. So try out 18 through 21. Pause the video and try these out. So if you tried this out, you should have gotten -3, because 1/5 to the -3 equals 125. So again, it flips from a fraction to not a fraction. So in order for that to happen, then we have a negative exponent because it flips it. And then 5 to the third power is 125. The number 19, it would be 6 squared is 36, so the answer is 2. 2 to the 5th power is 32. Then, now look on this one, we have a larger number to a smaller number on the right side. So in order to make that smaller, we're going to take 1/3. It's a fraction as the answer, a third. So remember nth roots, it's cubed root of 27.